Kia ora Year 12 and Year 11. In this video, I'm going to go through an AS binomial question from the November 2019 paper. So if you're in my A-level class this year, this is one of the ones from the latest homework, and it's how to find the term independent of x when we expand out this expression. And then I'm going to do two similar ones, but slightly easier, looking at two different ways to find the coefficient of something when we do a binomial expansion. Now, the expansions I'm doing in this are AS ones, so we're working with positive integer powers only, and we're going to be using Pascal's triangle quite a bit. Let's look at this first one. We've got 2x plus 1 over 4x squared to the power of 6. And we're looking for the term independent of x. Now, there are two ways to do this. You can use what's called a general term, but I think you're more likely to muck that one up. So the way that I prefer to do it is to just write out the first few terms and get a feeling for the pattern. So in here, we know that we're working with the sixth row down of Pascal's triangle. So those coefficients are going to come out of that pretty easily. Now, once you get up past about 6, you might want to start not using combinations instead of doing this. But for this one here, the coefficients will be 1, 6, 15, 20, 15, 6, and 1, right? So we're going to be working with that row there. And then we're going to be using these two terms. So the first term will be simply 2x all to the power of 6. And the next one will be 6 times 2x to the power of 5 and 1 over 4x squared to the power of 1. So just remember the pattern we've got going on here is that these are always going to add up to 6, and this number is going to come from down here. And if you can see what's going on here, we've got this is going to be x to the power of 6 in here. When we expand that, this will be x to the power of 5 divided by x squared. So the pattern here is that we're going down in powers of 3. So we've got 6 and then we've got x cubed. So the one we want is going to be the next term, right? So it's going to be 15 times 2x to the power of 4 times 1 over 4x squared all to the power of 2. Okay, and again, the 4 and the 2 are going to add up to the 6. All we have to do now is to figure out what this is. So 15 times 2x to the power of 4 over this will equal 15 times 2 to the power of 4 over 4 squared, because x to the power of 4 over x to the power of 4 simplifies away. And we're left with just 15. Okay, so I think that's the cleanest way to do this question. The other way to do it, though, is to use the idea of a general term in a binomial expansion. So here we had 2x plus 1 over 4x squared to the power of 6. And that equaled 6c0, 2 to the x to the power of 6 minus 0, 1 over 4x squared to the power of 0, and so on. In general, we can write out the term as 6 choose r times 2x to the power of 6 minus r times 1 over 4x squared to the power of r. And you'll find this is in the AS textbook. I think it might even be on the formula sheet. What we're looking for here is that when we expand all of that out, we end up with x to the power of 0, right? Because that's what it means to be the term independent of x. So what we're doing now is we're going to solve for r. Now, hopefully you're already seeing that this is a ton more work, right? But I'm going to go through with it just to show you that this will get us there as well. So we've got 6 choose r, which is 6 factorial over this, times 2 to the 6 minus r, x to the 6 minus r, over 4 to the r, and x to the 2r. What we're looking for now is how to get this equaling 0. So we've got x to the power of 6 minus r minus 2r has to equal x to the power of 0. Going really slowly, we get 6 minus 3r equals 0. So we need r equals 2. And now we're going to substitute it back, the 2 back into here, and we're going to find that all of this works out to give us 15. So this is sometimes a good strategy, but it's not a strategy that's going to be an efficient one for this problem. Right, so 2 to the power of 4 there over 4 squared. And you can see that they simplify away. This is, however, good practice in working with combinations. So this is equal to 6 times 5 over 2, right? Because here, the 6 factorial over 4 factorial has a whole lot of common factors. Okay, so 5 minutes in, and all we've done so far is one problem. But I want you to see from that sometimes just the getting on with it, expanding out the series and looking for the pattern is by far the best way to go. I'm going to do 2 more questions now where we have to find a coefficient. And the first one is going to be one where we again use Pascal's triangle, this one here. And then in this one here, I'm going to use combinations. Okay, so if we've got x plus 3 to the power of 5, and we want to find the coefficient of x cubed, we're just going to start doing the expansion. Scribble out Pascal's triangle again. And this is the row that we want. So x plus 3 to the power of 5 will be x to the power of 5 plus 5x to the power of 4 times 3 plus 10x cubed times 3 squared. This is the one we want, so then it's dot, dot, dot. So that equals blah, blah, blah plus 90x cubed. So the coefficient of x cubed is 90. And just as a side note, if you're asked to give a coefficient, this is what you need to do, right? The coefficient is not the whole term, it's just the 90. It's pretty obvious, but it'd be a shame to chuck marks away on that. Right, then the next one I'm going to do is one where you can see that the numbers are a bit worse. So we were dealing with something to the power of 10, and we're looking for the coefficient of x to the power of 7. So you can do that one in exactly the same way using Pascal's triangle, but I also want you to be confident with using the combinations formula. So x plus 5 to the power of 10 is equal to this 10 choose 0, x to the power of 10 plus dot, dot, dot. Now, what did I say we wanted? Oh, we're looking for the coefficient of x to the power of 7, right? So you can see in here, if it's x to the power of 10, the number in here is 0. So if we want x to the power of 7, we're going to have 10 choose 3, right? So this is all about spotting the patterns. And then it's going to be x to the power of 7 times 5 cubed. Remember, these will always add up to this one. So that's what we're after. So we have to evaluate this now. So 10 choose 3 times 5 cubed is equal to 10 factorial over 7 factorial, 3 factorial times 5 cubed. I'm going to simplify this by hand because for some strange reason I find that much more satisfying than using a calculator. 5 cubed is just 125. So let's go through and clean this up. Well, we've got 3 here, we've got 4 here. So what have I got? I've got 120 times 125. And if you reach for your calculator on that, I'm just checking that that's right. I think that's right. You should get 15,000. Okay, so that's the coefficient for that term. All right, if you've got any questions on these, let me know. There are lots of great examples of this on Dr. Frost, and I'm happy to set you some. And if you're watching this from the AS class later in the year, there are a few other binomial videos on the YouTube channel.